CodeLifeAI. Designing the building blocks of life.
Protein design starts with a goal. First, we decide what problem the protein should solve. It may need to bind a target, block a signal, or interact with a ligand. One powerful goal of protein design is to create binders, proteins that recognize a specific target and attach with high precision.
AI can generate many protein ideas quickly. Instead of just one idea, we explore many candidates at once. AI helps us search design space faster. Different goals need different strategies. We can design binders, generate backbones, or create sequences. The right method depends on the mission.
Not every protein design is a good one. We need to check which candidates are stable, precise, and useful. Then we keep the designs that match the goal best. We build a protein candidate first. Then we test whether it works well. If it can be better, we refine it and try again. Next, we find a real protein structure. We can search the RCSB PDB to get the starting model. This gives us a real structure to study and design from. Now we open the PDB file. This text file shows the protein structure in detail. The coordinates tell us where each atom is in 3D space.
Now we look at the active site. This is the pocket where the chemistry happens. We study its shape, residues, and charge pattern. That helps us understand how the enzyme works. Now we open the structure in the AI molecular editor. We can rotate, zoom, and inspect the active site. This helps us highlight the important residues and geometry.
We can use a simple command to focus on the active site. Then we hide the rest and keep only the important pocket region.
Now we use RFdiffusion. It is an AI tool that can generate new protein structures. Here, it helps build a new backbone around the active site. Now we use a config in RFdiffusion. It tells the model what to keep and what to build. The active site stays fixed, while the rest can be generated. Now we look at a fixed atom. It is an atom that must stay in the same position. This helps protect the active site geometry during design. Now we set the design rules in RFdiffusion. The config shows what to keep and what to build. Fixed atoms protect the important pocket geometry.
Now we redesign the whole enzyme backbone. The active site stays in place while the rest changes. This lets us build a new scaffold around the catalytic pocket.
Now we use protein MPNN. It designs the amino acid sequence for the backbone. This turns the structure into something we can build and test. Ligand MPNN. It designs the sequence with the ligand environment in mind. That helps the enzyme fit the pocket and the substrate better.
Now we verify the structure with AlphaFold. It helps us check whether the enzyme can fold as expected. We compare the predicted shape with the designed model.
Verify the binding with diffdock. It helps us test how the ligand fits into the active site. We can compare different docking poses. Then we choose the best-looking fit.
Now we check the final enzyme design. We compare the sequence, structure, and substrate fit. The substrate should sit correctly in the active site. The active site, backbone, and sequence all come together. From here, we can move on to DNA design. Welcome to CodeLifeAI.